Let's talk about Chapter 15, Processes Used to Form Plastics. In this chapter, we're going to discuss a whole bunch of different processes, okay? It's important to remember that there's a lot of variations and combinations of just a few basic processes. Many processes are going to be very similar to metalworking processes. For example, injection molding is very similar in operation to die casting. You force a liquid material with pressure into a die, cool it, and punch it out with an injector. The basic process is the same whether you're using metals or plastics. The major difference that comes up whenever you're doing plastics is that your temperatures are going to be far, far lower to get a plastic to be molten. Therefore, your equipment doesn't have to be as robust as something like a metal that has to be a lot hotter. So the dies can be made out of aluminum sometimes instead of being made out of tool steel. The hydraulics or toggles that hold the die halves together don't have to be quite as massive with plastics. This results in cost saving and easier changes in production. There are 8 basic forming processes: compression molding, injection molding, rotational molding, blow molding, thermoforming, extrusion, hand layup, and casting. For most of these processes, the material is heated to a softened state and then molded, usually between die halves. In casting, the material is going to be molten, melted in a liquid state before it's cast. This is also the case with injection molding, but they don't call it injection casting for whatever reason. In hand layup, the mold will be, in one place. It'll be an open mold, and the material is applied on top of it in layers. We're going to talk a lot about this in detail in the next chapter. Most of these processes will be the closed mold variety, meaning that the material is going to be pressed between 2 molds. The 5 major closed molding processes are injection, compression, rotational, blow, and extrusion. The usual process involves a 2-piece mold with a space for the product, known as the die cavity. The raw material will go into this space. It'll be held there by the die halves, and it will cool down until it's ejected out somehow. Normally, a press is used to maintain pressure to at least keep the die halves closed. Sometimes the die will have its own heating and or cooling system. So the material can go in, it can be heated up to an even more softened state, and more importantly, it can be cooled down while it's still in the die. Otherwise, it has to be taken out of the mold and die and cooled separately. Although some materials need to be cured after they come out of the mold, which we'll talk about in a minute in cold compression molding. The die must be well made. It's got to be the exact shape of the part you want, and it has to have a really good surface finish. The part is going to take on the finish of the die. So let's talk about some of the raw materials we're going to use for the closed mold processes. The first is roving. This is either woven or chopped up fiberglass. The resin has to be added to it to give it any kind of strength. Fiberglass is going to have a high strength to weight ratio. So whereas you could put fiberglass resin on just cotton cloth, you wouldn't get the strength that you would get from fiberglass. So it's going to come either with directional strands like this. This is a 90 degree, or something called biaxial cloth, which has 45 degrees, or it can come in random patterns, and this is what a chop gun will give you. The higher strength will come from the directional fibers. The next raw material is called preforms. These are for injection molding machines as well as compression molding and extrusion processes. It's usually in the form of pellets that are going to be melted or heated or whatever to get them into the shape they need to be in. Typically, they'll look something like this, just, you know, a jar of pellets, right? The advantage with having them in pellet or granular form instead of 4x8 sheet or bars, whatever, is that in a lot of these processes, they're going to be fed through tubing and, more importantly, hoppers. So you want this stuff to flow through the machinery. You don't want to have robots pick up big blocks of plastic and then melt it later on. The next are coated preforms. So this is going to be when you take your fiberglass roving and you go ahead and coat it with some resin, right? And then after it's coated, you'll press it into the shape you want in a compression mold. The next is called prepregs. This is a fiberglass material that has had resin added and it's partially cured. So it'll be partially cured, put into the mold, taken out, and then it will be fully cured with heat and or pressure. This is typically used with thermosets, as most fiberglass resins are thermoset in nature. The next is sheet molding compound, or SMC. This is also called flow mat or resin sheet. Machines are used to apply the resin and the reinforcement in a sheet format. It's rolled up with plastic film in between so it doesn't stick to itself, and it's saved for further use. It's rolled into big coils. This stuff doesn't have the greatest shelf life, so it's typically used in the plant where they're going to use it for something, right? So when the machines are ready to take it, you just feed it in and get your product out. The next is bulk molding compound, or BMC. This is a similar idea, but instead of having the fiberglass cloth, you'll just have a putty of some kind of resin with fillers in it. Fillers are added for a couple different reasons. Sometimes it's just to save money, right? The fiberglass resin is really expensive, so if you can just put talc powder, whatever in there, it'll eat up some of that volume and save you a little bit of money. Other times it's a structural reinforcement, so you could put chopped up glass fibers in there, or wood flour, or even aluminum powder to give the resin a little bit more strength, but not particularly directional. And then this is used in compression molding, injection molding, and extrusions. So let's chat about compression molding. This is going to be used for thermoplastics and thermosets. However, it's most popular with thermosets. It's going to use a matched mold, in between which will be the die cavity that the part occupies. It uses heat to cure the part after it's been formed. So the way it works is you get the raw material, whether it's roving sheet or bulk molding compound or sheet molding compound, place it in between the dies. It squishes it. In cold compression molding, the material gets crushed, right? It takes the shape you want it to, and you pull it out and you put it into an oven to cure. So you have essentially a two-step process. In hot press compression molding, the oven is in the die. So the die set will have some kind of heat capability. So you press the material, get it to the shape you want, the heaters in the die turn on, and it cures it right there in the mold. Both are used for medium to high production runs. Some examples are car parts, appliance components, office machine housings, tote boxes. Don't have a ton of examples, but this tray is something that was definitely compression molded. This is fiberglass, right? So what they did was took a sheet of probably prepreg fiberglass that already had resin in it, put it between the presses, crushed it into this shape, and then heated it, and you have a fully formed part. So let's talk about injection molding. This is a hugely popular process that a lot of commodities are made out of. It's a very high volume process. The machinery and the dies are very expensive, so they typically use this for big production runs when they have to make thousands of something, similar to die casting. In this process, a measured amount of liquid plastic is going to be forced into the die. The die is usually 2 pieces. The material will take the shape of the die cavity. It's going to cool down, usually with forced cooling in the die. So the die will have some kind of cooling system, usually just water running through it. When the part has cooled down enough to just keep its shape, right? It doesn't have to be fully hardened, but just enough so it doesn't deform. There'll be an ejection system, which is usually just pins, right? They're just little pins that push on the back of the part, pops it out of the die halves as they open up. The die halves close, and then a new amount of plastic called a shot is put in the machine, and it just keeps repeating itself. The parts that come out will be picked up by a person, a conveyor belt, a machine, or a robot, okay? One thing to remember with this process is there's always going to be sprues and sometimes runners. Sprues are just a little spout where the plastic has to go to reach the die cavity. So that's going to solidify as well as the part, so that's going to have to be cut off the part. The runners are little connections. Say you have enough space to put several parts side by side. You have to have a connection for the plastic to flow. That's the runner. So those have to be snipped sometimes. If you've ever put together a model airplane or a model boat, whatever, they come in a big sheet and all the parts are connected around it, and you have to kind of twist them to get the individual parts out. That's because of the injection molding process. They made that with one just shot of plastic, right? But the sprues and the runners have to be dealt with. In big production, they have literal robots that go in there and do all that stuff and throw them in a big bin, and other robots pick them out and put them in packages, okay? Some examples, besides everything, cell phone cases, electrical equipment, housings, toys, a lot of times, like I said, little model kits and stuff. Whenever you have to make a lot of something, especially out of thermoplastics, injection molding is a good option. So let's talk about rotational molding, or roto-molding. This is one that is picking up in popularity. It's typically made for seamless, hollow things. So balls, things like tennis balls, basketballs, can be made with this process. Those big barrel traffic cones, all sorts of tanks, agricultural spray tanks, that kind of thing. And even now they make kayaks out of this. So the idea is that you have a seamless thing. You don't have to weld the plastic, so you get a stronger structure overall with roto-molding. The plastic is spun around, and it uses centrifugal force to keep that plastic pressed against the outside of the mold. So what you end up with is a nice uniform layer of plastic that's spread pretty well. The design of the molds is a little bit simpler because you only need the outside. The inside doesn't need anything to hold the plastic against the outside because of the centrifugal force. So the molds can be a little bit simpler. So some examples of this, again, are traffic cones, trash cans are typically made with this, storage tank, sports balls. Okay. Blow molding is a process that makes hollow, thin, or medium-walled thermoplastic products. Very high production rates are possible. Some companies make 60,000 bottles in an hour with this process. Process starts with something called a parison, which is just a little tube of softened plastic in the general shape of the object you want to make. So a soda bottle will start out maybe an inch long, and it'll get blown to make the, a 2-liter bottle, right? The person is placed between a mold, so wherever the cap or the neck is going to be is locked, and then air is blown into the parison, and it gets pushed up against the sides of the mold. The molds are typically 2-piece, so that they can open up and the bottle can drop right out of the bottom, and then it just repeats the process over and over again. Some processes, instead of making bottles, they use sheets. So you can put 2 sheets on top of each other, have air blow in between, so you can make more rectangular shapes. And you can make all kinds of things with blow molding. One of the advantages is you get a pretty uniform wall thickness if it's been dialed in correctly. And again, that extremely high production capacity. This is how they make soda bottles and a lot of containers, little totes and things. Thermoforming. There's a couple different varieties, but they all basically work the same way. You're going to take a sheet of plastic, put it into a softened state, so add heat in some way, whether it's heat lamps or radiation, whatever, and you're going to pull it or push it onto a mold. In vacuum forming, you use a negative pressure to pull the sheet down onto the mold. They use this for all kind of things. Think about the inside of your refrigerator. This is how they make the doors in those goofy shapes that are kind of large, right? The advantage with the mold is that it can be very simple. It can be plywood, it doesn't really matter. It doesn't have to be made out of metal because you're not dealing with extremely high temperatures or high pressures. It doesn't take much vacuum to pull that thin, softened plastic sheet. Another type is called the plug-assisted vacuum forming technique. In this technique, sometimes the vacuum isn't quite enough to pull the plastic down, so you'll have something that looks like a piston come down and help push that plastic with the vacuum pulling on it. This would be used for thicker materials or things with funny shapes or really, really deep draws. Mechanical stretch forming is similar to the plug-assisted method, except that there's no vacuum. So you're just using some kind of piston to push down onto the material into the mold. Examples of this are, again, your refrigerator doors, luggage, auto panels. So think of your door panel in your car. These kinds of things will be made with these thermoforming techniques. So let's chat about extrusion and pultrusion. Extrusion is when you take molten plastic and you push it through a die to make a continuous product. Usually there's going to be a screw that takes that plastic from the granules and heats it up slowly and pushes it along into the extruder. So the die is the shape of whatever you want to make. So if you're making C channels or a round shape, the die will be that shape. Unlike steel, these dies don't have to be made out of tungsten carbide or some crazy material. They could just be steel or aluminum, whatever. They use this for making pipes, like PVC pipes, gutters, all sorts of plastic products that need to be long. In pultrusion, it's a similar process but more complicated, because what we're doing is adding continuous fiberglass fibers into that plastic. So this makes it very, very strong, but a lot more complicated because you have to twist that fiber and get it through the extruder with the plastic and the right heat all at the same time. But this is how they make, if you've ever been at Lowe's or you have one, those fiberglass ladders. If you look at the legs, they're an H shape. So they'll make these really, really long with pultrusion and then cut them down and then use them in ladders. Makes a very strong shape without having to go through the effort of hand layup. Another thing they use this for is fishing poles and fishing rods, right? They're usually fiberglass. And plastics can also be cast, similar to metals. One of the differences when you're casting plastics, especially two-part mixtures where there's no heat involved, is that you're gonna get a lot less shrinkage, right? So things like fiberglass don't really shrink that much. Any fiberglass that needs heat to cure can shrink, and they can shrink up to 20%. This can all be accounted for, if need be, by just rule of thumb and trial and error. One thing with casting that makes it different from injection molding is that casting doesn't need any pressure. The only pressure casting uses is gravity. The mold for casting can be simpler than molds for things like injection molding or blow molding, right? They can be anything that can stand the temperature of the plastic pouring, which is usually just a few hundred degrees. They can be flexible, so things like silicone can be used, and they can be disposable. So if you just need one or two things, casting can be a great way to go. Materials can be cured with an initiator or a two-part mixture or heat. Casting is common for plates, so things like acrylic or polycarbonate that are used for windows and skylights and all sorts of things. For whatever reason, in plastics, casting produces a superior plate. Nylon is popular with casting and is used in things like electrical plugs.